So now it's time to look at how we can throw exceptions inside our coroutines and how those exceptions are gonna affect the other coroutines and how it will affect also the parent coroutine. So how it will propagate to the parent coroutine if one of the child coroutines it throws an exception, how it's gonna affect the other child coroutines, and also how it's gonna affect the parent. And for that, I'm gonna go down here and I'm gonna create another private suspending function. I'm gonna copy this one and I'm gonna call it getData3. So let's paste it here and let's call it getData3 fake work 3 starts and fake work 3 finished, and let's return result 3 here. Now let's go up here and let's create another coroutine here. So we type val job3 equals, and we're gonna create a coroutine using the launch coroutine builder, and we're gonna add a print line here, and we're gonna type get data3, and now for the parameter thread name, I'm gonna type thread.currentThread.name, and that is gonna give us the name of the current thread. Now if you run this code, we get all of our coroutines starting at the same time, and we get then work 1 finished. Actually, let's go down here because I think I missed something. So get work 1 finished, work 3 finished, then we get work 2 finished, we get result result 3, result 1, result 2. So our code works okay, and we have only 2 seconds for all of our coroutines, even though they together, if they are executed sequentially, will take 6 seconds, but because they are starting at the same time, we only have 2 seconds. Now let's say that I throw an exception inside the coroutine. So let's say that I throw an exception inside this suspending function. So I'm gonna type here throw. So this is how we can throw an exception, and I'm gonna throw a generic exception. So exception, I'm gonna type here, and I'm gonna type the text error while getting the data in get data 1. And I am curious about how this is gonna affect the other coroutines which are currently running inside our coroutine scope, and how is that gonna affect our coroutine parent. So what I'm interested in is if the parent will fail or the parent will say that it has succeeded. So now if I run the code, let's see what happens. So now we get an exception, and we get main program start, fake 1 more starts, and we get an exception, and we get our message error while getting data in get data 1. So we get the message that we typed here inside our exception, and that exception is the message we get it from here. So we get here. Actually, no, not from here. Let's go down here. So we get here parent job failed, error while getting the data and get data 1. So this is the message that we get here from here. So the parent, because first what happened, because we throw an exception in the job 1, it also caused the other jobs, job 2 and job 3 to fail, to not work, and it also caused the parent to fail. And we know from the previous video that you can surround this in a try and catch. So you can type here try catch, and we can type here x, and we're gonna catch exception, the exception that we throw in the child, and we're gonna put curly brace, the print line here, and we're gonna type exception session cut safely, and we're gonna put $sign x dot message, and let's change this to cut because that is bad English. All right, let's also add the finally block here, finally, and let's print line, let's say resource sources closed safely. Alright, now if you run this code, because now we are actually I should put this inside our try and catch. So let's so you get the same error because I didn't put the code there. So let's copy our code which generates the exception. Let's paste it inside the try. So what we're saying now, hey, I know that this can potentially throw an error. I know what the error is. It's this exception that we define here, but anyway, try to run that code, and if an error occurs, just catch that exception and execute the code. And what I'm curious about is if the next coroutines are gonna run and if the parent is gonna fail or succeed. So if I run this code now get fake work one start, fake let's actually go up here to see the output. So get main program start main, fake one starts, and we get exception cut safely error while getting get data 1. So it caught the exception that we thrown in our get data 1 function, and then it says resources closed safely. So this is the message from the finally block. And then we get our fake work to start. So our second coroutine, now it's working. It's not affected by the fact that it was an exception throw in the first coroutine. And we get also fake work to start. And we get the results for fake fake work 1 and fake work 2. And also for fake work 2 and fake work 3, because we get result 3 here, result 2 here, sorry, and result 3 here. And very important, the parent job succeeds. So we get parent job success. So the parent didn't fail now. So the error didn't propagate to the parent, and it made the parent to fail. So this is one way to avoid that error. But let's say that now I throw an exception in the second function. What can I do? So let's say that I type here throw, also exception, and let's say that's gonna say error, so quotation marks, error while getting the data in get data 2. Let's see what happens now, because as we saw previously, now if we run our code, it's gonna make our program to crash. And we can again surround this in a try and catch block, and so we can type here try catch, and we can type here x and exception. We can add a print line here, which is gonna say exception safely. So we're gonna type here $, x dot message, also the finally block. So finally, also print line, which is gonna say resources closed safely. So the finally block is gonna be executed no matter what happens here. So let's move the code that we have here inside our try. Let's paste it here. Now let's run our code. And because we've surrounded our code with a try and a catch block, it also didn't cause the third coroutine to fail, and it also didn't cause the parent. So we get here parent job success, and we only get result 3 because the other coroutines for the other coroutines we get so we get here error while getting the data and get data 1, and then we get exception cut safely error while getting the data and get data 2. So we only get the result for our coroutine 3. So but if you look at this code, it's kind of messy, because imagine if I have 10 coroutines or 20 coroutines, then what can I do? I can surround them with all of them with try and catch. I can do that, but that is gonna look messy. And there is another way to handle all of this using what is called the coroutine exception handler and a supervisor job. So What we can do instead of surrounding our code to try and catch, we can delete this code that we have. So we can delete this. Let's delete this. Let's delete this also. This is also. Let's press Ctrl Alt L to format the code. And now if you run the code, you get our app is gonna crash. So our app crashed, and also the parent failed. You get error while getting the data and get data 1. Now, instead of surrounding our code with try and catch, we can create what is called the coroutine handler. And to create a coroutine handler, we can type here val, and we type handler, and we have a suggestion for the type coroutine handler, and we put equals coroutine exception handler, and this is gonna be a lambda expression, and for the first argument we're gonna put underscore because we're not gonna use the first argument. You don't need that argument. And for the second argument we type exception. So we type exception, we put the arrow sign, so because it is a lambda expression, and we add a print line here, which is gonna say print line error in one of the children, and we put colon, and we put $sign exception that message. Now what we can do now, instead of surrounding surrounding each particular child coroutine in a try and catch block, we can pass this handler that we created here to the parent coroutine, and if an exception is thrown in one of the children, that exception is going to be handled by this handler that we created now. But this only works if we use our handler with the supervisor scope in conjunction. So if I only pass here, if we put here parentheses, and if I type here handler, so this now is gonna handle if there is an exception thrown in one of the child coroutines which are inside the coroutine scope. So now if you run this code, now we'll get an error and the parent will fail because we also need to use the supervisor scope. So we get error in one of the children. At least our app didn't crash, so we didn't get the exception, but we get error while getting get data 1, and parent job failed. So our parent job failed, and it also caused the other coroutines to fail. And to use to make use of this handler, we can type here supervisor scope. So supervisor scope, we choose this one, lambda expression, press enter, and we move our code which we want to supervise if you want. So you want to look at this code, at those coroutines, at those child coroutines, to see if they throw an error, and if they throw an error, that error is going to be handled by our handler that we created up here, and it's gonna show this message error in one of the children, and it's gonna say exception. It's gonna output the message for the particular coroutine. So we surrounded our child coroutines with the supervisor scope lambda expression. We pass our handler to the coroutine parent, and now we're saying, hey, if an error is thrown in one of the child in all of the child coroutines, then handle this error and make sure that it's not propagating to the next coroutines, and it's not affecting the parent coroutine, the coroutine that is which is the parent for the child coroutine. So now if you run this code, look what happens. So previously we got that the parent failed, and now we get that error while getting the data in get data 1. So we get error in one of the children. So we get the message that we have up here, error in one of the children, and we get exception that message. So we get this message, and then we get fake or to starts, and this suspending functions, this coroutine also throws an exception, so you get again error in one of the children. Now you get error while getting the data and get data too. Then we get fake work 3 starts, so our third coroutine starts, and we get fake work 3 finish. So now our third coroutine is not affected by the fact that the first and the second coroutine. So our third coroutine is not affected by the fact that our first and second coroutine failed. And we also get result 3, and we get parent job success. So the parent now is success, is not showing an error. So this is how you can throw exceptions, and this is how you can handle those exceptions using the handler, the coroutine exception handler. You can pass it here, and you surround your code, your child coroutine with the supervisor scope, and it's gonna be handled by that, instead of surrounding each individual coroutine with try and catch, and that's gonna look messy. But you can just type this, and that is gonna take care of the errors, so that the error is not propagating to the next coroutines and to the parent coroutine. And you can also throw another exception, which is called a cancellation exception, and that's is a special exception. And if you throw that exception is not going to cause the other coroutines to fail. So there is another exception that you can throw, and that exception is not going to propagate to the other coroutines which are currently working in that coroutine scope, and is also not going to propagate to the parent. And let me show you how you can use that. So let's comment this code. And instead of exception, we can type here this special exception called cancellation exception. Now, if I remove the supervisor scope, let's say, and also the handler, as I said, this is not going to propagate to the other coroutines, and it's not going to affect the parent. Alright, so if I run the code now, let's press Ctrl+L to format the code. So we get all 3 coroutines starting, and we get work to finish. So work 1 didn't finish because we throw that cancellation exception, but it didn't cause the other coroutines, respectively coroutine 2 and coroutine 3, to fail, and it also didn't cause the parent to fail. As you can see here, the parent is success, so even though we didn't use any kind of try and catch or the supervisor's job with the handler. So this is another session that you can throw in our code. And I'm gonna end this video, and in the next video we're gonna look at how you can execute coroutines sequentially, concurrently, in other words in parallel, and lazily.